Okay, good afternoon. Hello, good afternoon.
Good afternoon, sir.
Yeah, is there any coordinator? So are
Hello,
we
Yes,
good
going?
afternoon, sir.
Mr. Prasad is there.
Good afternoon, sir.
Yeah, good afternoon.
Sir, shall we start? Oh,
Yeah, I can start. I'm just thinking whether
okay,
are there any more students to join?
okay, sir. Okay, so give me a few minutes to introduce about yourself to the learners, sir.
Okay.
Good afternoon, all. Today, resource person is Dr. Varuna Adiariwattage. He is the senior lecturer of Department of Civil Engineering, Faculty of Engineering, University of Moratuwa. Thank you very much for accepting our invitation. Over to you, sir. Thank you, sir.
Okay, thank you very much. Let me share my. Okay. I hope you can see the screen I'm sharing.
Yes, sir, it's visible.
Okay.
Recording in progress.
Okay, good afternoon, everyone again. Sorry about the slight delay. My video camera is not working right now. So I tried to fix it, didn't work. Sorry about the fact that I don't have my video on. Now, again, just to confirm, I hope you can hear me as well as you can see my screen.
Yes, sir.
All right, good. Right. So today we are going to talk about fundamentals of transportation. So the module is fundamentals of transportation and logistics. So my discussion will be mainly on transportation and what is the role played by transportation in logistics and in supply chain, and how we go about planning transportation component in our day-to-day operations. Right. So the content that I'll be covering is mainly be talking about principles of transportation, the fundamental elements of transportation, what is its role in the society as well as in the economy in general, transportation in supply chains, few transportation strategies, and how we can use various analytical methods to solve transportation planning problems. Right? Okay. The desire for movement, that's basically what we are talking about. How important is transportation for us? And why we need transportation is the big question. And in fact, so we are kind of in a very modern era right now. And as you all agree, transportation is a basic necessity for our modern lives, right? What is the main reason why we need to transport ourselves? We need to transport ourselves and we need to transport various goods as well, right? So what is the main reason for that? Right? So the main reason, as we all know, is that we can't find things what we want at the same place, or basically where we live, and in a very short walking distance, or from our neighborhood or from our garden, we can't find everything we need, right? So our needs have expanded a lot, right? Not like the good old days. I mean, not like the era where people were like tribes that were living in forests, didn't need much transportation. The needs were very basic and didn't need much transportation except for hunting for food and things like that. But our needs are very specialized now. So these specialized needs are available in specialized centers, and these specialized centers are located in specialized geographic areas or locations because of those various due to efficiencies that they enjoy because of being in those locations. So then we need to move ourselves those centers. So that's the basic reason why we need transportation, right? So because of that, as you know, different activities we need to interact happen at different locations, right? So we need to do activities of work, we need to do activities of recreation, we need to do activities of school, education, we need to do activities of shopping, and various other activities are there. So those activities, satisfy various needs that we have, and we need to interact with these activities. And these activities happen to be in different locations because of various reasons. Because of the unevenness of availability of resources, right? Therefore, we need to move ourselves among these locations. And this movement is facilitated by transportation, right? So we need to transport ourselves. And the same reason why the goods are also getting transported, right? Right. So transport, one of the very basic components or considerations about transportation is that it is a derived demand, right? It is a derived demand. Why it is a derived demand is because transportation is not consumed for its own utility. It's not consumed for its own utility. It's not consumed for the sake of consuming transportation, right? But we consume food, right? We consume various other things, right? Services, right? Those things we consume because of the value we have in those things itself, right? But transportation we consume because we need to do something else, right? So transportation has a derived demand because of we need to do other things. The other things are in different locations, spatially distributed. So therefore, in order to enjoy those things, we need to transport ourselves, or otherwise the things need to be transported to ourselves, right? If we want to eat a pizza, either we go to a restaurant or we need to bring the pizza to our residence, right? So either way, transportation has to happen, right? So this majority demand or majority requirement is what we are talking about, right? So we are planning for transportation for this majority requirement. But there is a minority that do transportation for the joy of traveling, which is a very minority requirement. Apart from that, all the other transportation happens for a specific purpose, right? So we move goods, we move raw material from where they are extracted, maybe a mining site or maybe a cultivation, whatever, and to a manufacturing plant in order to add value, in order to create more value, right? Not because transportation itself doesn't generate, like if we are transporting, let's say, we are collecting milk from the farmers, and then we need to transport that milk to a chiller somewhere, and then from the chillers to processing plants for various dairy products. Not that transporting them in a Bowser doesn't do anything, right? Only that it shifts from a place where it is in surplus and to a place where it is more valuable, right? Right. So it is in with farmers and they are demanded by consumers. So then, what we call the place utility. So transportation creates that place utility, right? So because of that, we need to transport. Same ourselves, right? We are at home and each one of us have some speciality, right? Maybe some professional, right? Doing some sort of a specialized activity. So being just at our home doesn't do anything for us. Our value is where we are working, our specialized work centers. So we need to move ourselves from our residence to those specialized work centers where our value is enhanced. So we have more value there. So our work is valuable. So we need to transport us. So that's the basic reason why we call transportation has a derived demand. Right. Okay. Yeah. So the same thing, right? Same thing. Transport is is consumed because we need to consume something else at the other end, right? A few reasons why people in the modern world need transport, right? Probably you know this already, right? As I just explained earlier, right? An acceptable collection of goods and services we require in our day-to-day lives cannot be obtained from one location, right? And cannot be obtained for where we are living, basically, from our neighborhood or from our house or in the surrounding of our house or dwelling, we can't obtain, right? In the modern civilization, we can't do that. Because why can't we have things we want in places around us? Any reason why? I mean, it would be very nice, isn't it, if we can have a haircut and go to school and go to a restaurant, everything next door, just around our house would be very good, but it doesn't happen always like that. I mean, there are a few places like that, like if you live in some, an apartment complex, multi-purpose development where you have everything provided, yes, for certain things, yes. But for many other things, you might have to travel. Why do you think why we need to travel? Why we can't have everything we need in short walking distance?
Due to the scarcity of resources.
Exactly. And we can say the specialization is also because of that, right? So in the modern era, we have developed specialization, like labor specialization, geographic specialization, because it has various efficiencies, right? It's always good to be specialized in something, right? And we have developed certain specializations. And these specializations, in order to have a certain specialization, we need to be in a certain center, like in a workplace, where this specialization has a good demand, right? Good demand. and the scarcity of resources, which is geographically in different locations, different resources are available, and the same thing, right? Because of that, we can't have everything in around us, which would be very inefficient, right? So then we need to go to those locations to interact with them, which is more efficient way of doing things, right? So when there is specialization, there is more productivity, and there is more value, and there is room for innovation, right? When you are specializing in something, you can innovate. And so that therefore specialization happens, and transportation is also creating this specialization or making it possible, right? So that's one of the main reasons why we need to travel around, right? And apart from that, transportation has various other requirements, like political and military role is also there for providing requirement of transportation, right? For defending the country, national security, you need to deploy security forces, deploy these security forces and their equipment in different locations of the country, and also to integrate various regions or societies of the country. You need to provide transportation, right? So transportation creates social integration, right? And then it creates new markets, and it aids in national economy, as well as it has a certain political role as well. And the military role I just explained, a lot of large countries like United States, India, they have developed their national transportation network to have a certain role in their military activities as well. So in order to deploy their military forces in quick time at different locations, strategic locations, whenever they require, right? Yeah. So transportation also play a great role in value, land value, right? So transportation can play a big role in shifting land value. So you can see whenever transportation is, so I mean, when you go look around, whenever we want to buy some property or something also, we always look whether we have short walking distance to a bus terminal, or whether we have wide roads. Transportation is one of the key requirements, right? We look for. So therefore, having transportation affects land value, right? And then it has a certain cycle, which I will explain later on, where then that land value generates activities, and again those activities have a feedback on transportation as well, right? Okay, so now therefore transportation has a very special role in society, right? Advances in transportation has made possible changes in the way of living and the way in which societies are organized. Therefore, have a great influence in the development of civilization, and which we already know, like how civilizations have evolved, cities were developed, countries were formed based on transportation aspects, right? Good old days, transportation were provided by waterways. So cities were established nearby rivers, and then as technology developed, cities were developed at important strategic intersection of roadways, rail tracks, and things like that. And transportation helped expand cities, which we call now urbanization, right? So transportation has played a great role in forming our civilization, right? In the development of civilization. It evolves our behaviors, right? How transportation is provided, what technology development in transportation keeps evolving our society. Right? And also transportation consumes a lot of resources also. So it consumes time, fuel, materials, and land. It is not something that comes free of charge, right? It consumes, right? And as I told you, so one of the main effects of transportation is it facilitates specialization of labor and geographic specialization, right? So transportation connects where resources are available in abundance to their demand points, right? So resources are available in one location and they are valued at a different location because of the demand. And so the transportation is able to bring those resources to where they are valued. So then more value is, utility is created by transportation. Right? And it is same for goods and people, right? It's same for goods and people. And that's the fundamental reason why we need to transport ourselves, right? Because of this specialization is one of the reason why economic development is, the basis for economic development. And therefore, transportation plays a very important role in terms of economic development, right? So you can see in most of the developed countries, right? Probably you may have visited both developed and developing and underdeveloped countries, and you may have a good comparison of how transportation is available in those countries. You can see a clear correlation with transportation infrastructure and availability of transportation, or the level of technology used in transportation between developed countries and underdeveloped countries. So where they are in most developed countries, transportation is always at a very high level of development. So transportation has a clear correlation with economic development.
Sir, excuse me, can I
Yes.
disturb you?
Yeah, go ahead.
Sir, we haven't got this presentation because LMS is not working since yesterday. Could
Okay.
you please share it to chat box?
You want right now or after the lecture?
After the lecture. Yes,
Okay.
please.
So yeah, I'll make sure that I share the slides as a note. Right. So that therefore transportation plays a very important role in our society. And also, as explained earlier, transportation enables social integration. Like different societies, different regions, different ethnicities can integrate, which, in the form of tourism, that is one way of that integration happens, right? We can travel to other places easily, with less cost in terms of time as well as money. We can travel to places, so places become reachable, and then we can go reach those locations. And and also new markets are available for industries, right? So this social integration is also very important for the society to sustain. So transportation is one way of providing that, right? Now, of course, the IT infrastructure is also providing a great deal of interaction among people, without transportation, but physical movement it plays a major role in interactions. Right. So the economic role of transportation, well, yes, I mean, it's more or less the same. Like transportation is essential in the modern world because it connects people to specialized work and links geographically specialized regions. So as labor becomes more specialized and industries concentrate in certain areas, transportation enables workers to reach places where their skills are more productive, right? So this increases individual earnings, raises national productivity, supports complex economic systems that define modern civilization, right? So that's the main reason why transportation plays an important role in any country, right? So it connects people with places of work. So places of work is places of specialization, and it connects markets with production plants or markets with other material or goods, which adds value, which creates value, right? So the production, distribution, and consumption can happen. So transportation facilitates this, right? So without transportation, none of this can happen. Raw material cannot come to factories. Finished products cannot go to markets. People cannot reach their workplaces. So we are kind of, stuck in our own dwellings, doing various other things to survive ourselves, which was long gone, right? So therefore transportation creates this place utility and time utility, right? So that's kind of the fundamental reasons for economic development. So transportation creates the conditions that allow specialization to function because it provides place utility. It puts people and goods in the correct locations where they generate the highest value. And time utility, it ensures that the goods and people arrive at the correct time for economic activities to proceed smoothly, right? So it allows things to be transported when it is needed, right? When it is needed. So it creates both place utility and time utility, right? So in essence, it transports goods and people to where it is needed and when it is needed, right? Which creates highest economic value. So that's the overall basis why transportation is important for our modern society, right? We can look at transportation in two perspectives. So what I'm trying to do here is kind of break transportation into several components and try to evaluate various components of transportation, right? So transportation, when we say, is a broad term, so it is viewed in different perspectives. One of the main two players in any economy is the state sector, the public sector, and the private sector, right? So as you can see, transportation infrastructure most of the time is provided by the state sector, right? Roads, ports, airports, rail tracks, a lot of those things are state-owned or public sector. But operations are private sector. The roads are owned and operated, maintained by RDA or these provincial road development authorities, local authorities and municipalities. But vehicles that go on the road are private, right? So you and I and companies, various private organizations operate on them, right? So it's important that we look at this different perspective, how private sector and the public sector look at the transportation, right? Public sector defines transportation as the effective and efficient movement of people and goods from one place to another. That's the state. That's how the public sector, the government, looks at transportation. So the government or the public sector goals are are more broad goals, right? They are to provide mobility, accessibility, safety, national integration, disaster resilience, and social inclusion, right? So that is what we mean by effectiveness, right? It should have an impact. It should be effective, right? So transport systems to achieve social goals: mobility, accessibility, safety, national integration, disaster resilience, social inclusion, as few, right? There are others as well. So you can see that those social goals are very broad and national level. So that's the view of the public sector. And efficiency, right? So are resources used optimally, right? That is efficiency. Transportation is provided effectively and efficiently, right? The funds, land, infrastructure, energy, whether they are used optimally, right? Whether we are minimizing congestion, whether we are minimizing emissions, whether we are minimizing travel cost, whether we are minimizing public expenditure, and whether we are maximizing public utility, things like that, right? So that's or we need to maximize the influence on economic development. So we want to see that transportation achieve these goals. So the government's responsibility is to ensure that the entire system works for the public good, right, or the public benefit, right, with social welfare, in other words. So that's basically the view of the state sector, the public sector regarding transportation. As you can see, transportation, most of the infrastructure, right, very expensive components of the transportation system is state-owned, right? It views transportation as a public utility, right, a service essential for social welfare, national competitiveness, and the functioning of daily life, right? So the government's viewpoint or the public sector view in terms of transportation, it should provide benefit to the society, right? So to maximize the benefit to the society is what the public sector is trying to achieve in terms of providing transportation, right? So what is the view of the private sector? So overall, private sector is more inclined or more focused on profit maximization, right? It is not public welfare, right? So every private organization, we can say individuals, we ourselves, when we are on the road, we are, very selfish, right? We are highly selfish, so because we want to minimize our travel time, right? When I'm trying to choose a road to travel, let's say I'm going to work from home let's say I'm going to work at University of Moratuwa. Then I'm choosing my route in order to minimize my travel time, right? But because I'm choosing my route, I may be congesting certain intersections for others, right? I don't care, right? That because I'm not looking at the entire road network and try to minimize everyone's travel time. I'm trying to minimize my own travel time. So that's what everybody is doing, right? Everybody is doing. So that is what the private sector is more interested about, to maximize our benefit, individual benefit, organization benefit, right? Or in other words, place utility and time utility, right? So move goods or people to locations where they are higher value. Product in a warehouse has less value than the same product on a store shelf. Time utility, ensure the movement happens when it is needed. Delivering raw materials on time prevents production delays, right? So that's the objective of private sector, right? For private operators, transportation is an economic activity aimed at meeting customer demand efficiently, competitively, and profitably. So the private sector is always operating in a competitive environment, isn't it? So we need to beat the competition and try to maximize our benefit, right? So the private sector is not looking at the social welfare, right? So you can see there are different viewpoints in terms of transportation of both public sector and private sector, right? Why it is important? The importance is because of the interaction. You can see, as I will explain later also, transportation infrastructure is public owned, right? State owned. Roads, rail, air routes, sea routes, ports, airports have majority public stake. So, but they are operated, most of the time, operations are done by private sector. Right? There are certain situations that operations are done by public sector as well. Let's say, state-run railway, state-run bus services are there, but majority freight is mainly run by private sector, right? Likewise, so operations are done by private sector, right? So the two entities who operate the infrastructure and who own and maintain the infrastructure and who operate the services have two different objectives, and they can be conflicting sometimes, right? So therefore, policy making in terms of transportation have to look into this differentiation in the goals in order to achieve sustainable development. Now, for example, as I told you, so the public sector wants social welfare, right? So we want to minimize congestion, right? Government wants maximum utilization of land that are devoted for transportation. And if we look at the private sector, what does private sector want? Private sector wants shortest travel time, right? Higher speeds, less delays, right? In order to do that, when they are consuming these resources, they may create congestion, right? So as I told you, we all want to minimize our travel time. So we all try to stick to the shortest path, right? So if when we all stick to the same shortest path, we congest the roads, right? So then everybody is suffering because of that. They are wasting time, emission is increased, noise is increased, and people are adversely affected because individuals are trying to maximize their own benefit. So then what happens? The public sector brings in regulations. What are the regulations? They might bring in, congestion pricing. They might, put certain restrictions on vehicles entering to certain parts of the city, or they might put a tax on emission and things like that. They try to regulate and road pricing. Like, when we want to travel on the highway, we need to pay a price. So likewise, they regulate transport infrastructure in order to minimize these externalities because of consuming them private for individual benefit, right? Okay, so that's basically an introduction to transportation, right? What is its role and what are its different perspectives in terms of public sector and private sector, how transportation is, what are the expectations in terms of transportation, right? Now, let's look at what we call transportation systems, right? So this word is very popularly used with transportation, right? Transportation systems, right? So transportation systems can be defined in various scenarios, okay? Even a vehicle that is on the road is also a transportation system, right? So it has multiple components, and those multiple components work together in coordination to achieve certain transportation activity. When I try to ride a motorcycle or a foot cycle, that is also itself is a small transportation system, right? And also we can look at transportation as a very broad system, right? National road network, national railway network, or the entire transportation system of a country, right? Air transport network. Like, we can have very broad system definitions as well, right? So transportation systems can be defined in different scenarios. There is no real universally accepted definition for transportation system. But in general, we can separate a transportation system to main components. Those components are fixed facilities, flow entities, control systems, and transport users, right? Now, let's take, for example, the road network, right? The road network is the fixed facility, right? So it provides different links from city to city, within a city, right? and also you can have various terminals, rail terminals, air terminals, ports. Right? Those are fixed facilities, right? So they provide the infrastructure for the transport to work on, right? Transportation they facilitate the transportation, right? The physical infrastructure, right? You need those, right? And then you have the flow entities. So what are the flow entities? Flow entities are the things that flow on these infrastructure, right? Usually they are vessels, we call them, right? So on air routes, even though they are virtual, but it is an infrastructure. You can see air routes, though we don't see them, they are virtually there with navigational infrastructure, right? You have satellite navigation, you have ground-based navigational aids. With all of that, these air routes are marked, right? Geographically, they are marked where aircrafts can follow them to safely navigate and provide safe and efficient transportation, right? The flow entities. So the flow entities are the entities that travel along using this infrastructure, right? Like you can have automobiles, cars, motorcycles, three-wheelers, lorries that go on the road network, right? And then if you look at a public transportation network, public transportation system, you can have buses, rail, and taxis, various things, trams or things like that, that give public transportation, right? Vessels, ships, boats, anything like that, right? That flow along these fixed using these fixed infrastructure, right? Now, you have fixed infrastructure and then you have the flow entities. Are those enough? Are they enough? What else you need? Just because you have roads and then you have vehicles, can you travel safely? You can travel, of course, but safely and efficiently is in question, isn't it? What do you need?
Regulatory body or control system.
Yeah, we need control systems. We need something to safeguard the system or make the system sustainable. Otherwise, it will fail very quickly, right? So if you have roads without traffic signals, what will happen? People will, you can see what happens during the rush time when the signals are switched off, right? Hopefully the police officers are there, but if they are not there and if there are a power outage, nobody can go through the intersection. We are all stuck, right? And so that's one reason. So we need something to control. I mean, long time ago, when the demand was very, very minimum, we didn't need a lot of controls, right? The travel was slow and few vehicles were there, few people traveled. You didn't need a lot of control, right? People could travel as they want, but now the demands are very high. A lot of people need to travel, and therefore, safety and efficiently to manage this transportation system, you need to control it, right? Otherwise, safety is one of the reasons why we need controls, right? As I told you, one example is traffic signals. So without traffic signals, efficiency is dropped, right? Efficiency is dropped and also safety is compromised, right? So we can see in traffic signals only certain directions that does not conflict with each other is permitted through the intersection, and they are rotated according to a certain time intervals we call phasing, to make sure the entire intersection operates efficiently, right? Minimizing delay, right? And also it can prevent conflicts as well, right? If traffic signals were not there, certain intersections can cause fatal accidents because people try to go in conflicting directions at the same time through the intersection. And controlling systems are there in aviation. Controlling systems are there in freight transportation, right? To make the transportation system safe and efficient. And this controlling system also involves administration as well, right? Now, when you take rail transport, public transport, they have their controlling, the signal or the controlling centers are there, as well as administration is also there in order to manage the fleet, right? In order to schedule the vessels, in order to schedule the fleet, schedule the labor or the the crew. This a whole system, establishment is required for administration of the transportation system. Otherwise, it cannot function efficiently, right? So these control systems mean both controlling the transportation as well as administration. Okay. And then you need transport users. What is the importance of transport users? You have fixed facilities, flow entities, control systems. Then why do you need transport users? What is the role they play in the transportation system? So having the fixed facilities, so I have the roads, okay, I have a road, I have a vehicle, right? I have traffic lights, and I have all the other road signage in order to give, ensure safety and all that is there. So if there are no road users, what happens? What happens if there are no users? Will there be a transport system?
It is waste of money, maybe.
It can be a waste of money. Correct, because you basically have an empty infrastructure and without any users. But the transportation system does not function, isn't it? Right. So transportation, yes. We can see transportation as flow of vehicles, flow of aircrafts, flow of goods. They just don't flow like a river flow, isn't it? All right. A river will flow from high country to low country, but transportation doesn't happen that way. Transportation flows happen because of needs, necessities, utilities, isn't it? Right. So it is the demand, right? It is the people. I need to go to work, so as the entire community need to go to work. So transportation flow happens from suburbs to the city center, right? And people need to consume goods. People need to consume various commodities. So raw materials travel to manufacturing plants, and manufactured goods travel from manufacturing plants to marketplaces because of that pull by the demand, right? So the users need to be there in order to drive this transportation system. So they are the important elements of a transportation system: fixed facilities, flow entities, control systems, and transport users. So what are these fixed facilities? Right. So the fixed facilities, as I told you, are our roads, airports, seaports, right? Bus terminals, rail terminals. Right? So these fixed facilities provide the spatial structure for transportation activity. Right? Transportation is a physical thing, unless that you are in a future where Star Wars is going to be like you can do teleporting. We need this physical infrastructure in order to channel ourselves and goods from one place to another efficiently. Flow entities, as I told you, are the vehicles that flow within these transportation infrastructure, right? So something need to hold this infrastructure, right? You need intersections, you need interchanges, so you need roads, terminals, and various nodes like that. And then you need the flow entities, the vehicles, right? Right. So all of these are very important when we are planning transportation systems, right? Control systems. So the control systems are technological ways in which the vehicles are guided either automatically or manually. Flow control consists of means that permit efficient and smooth operation of stream of vehicles and the reduction of conflicts between them. Right. So the primary objective of flow control systems is to safeguard safety, efficiency, as well as so that's controlling the traffic flow, either aircrafts or vehicles or vessels or freight or things like that. And then you have administration also in terms of control systems. How do you assign cargo to vessels? How do you assign vehicles to different routes? How do you, assign crew to different vehicles and routes, things like that. Administration component is there in order to optimize this transportation system functions, right? So they are considered as control systems. System users, as I told you, is very important for a transportation system to work because they ultimately are the decision makers, right? So the transportation systems are formed and their configuration, their structure is defined by the needs of the people and the goods that they consume, right? So people decide when to travel, where to travel, why they need to travel, and how to travel, right? And how frequently they want to travel. So the transportation systems are developed in order to cater to this demand. So the system users are very important, therefore. So they are fundamental or a starting point in the planning phase of any transportation system. So when we are planning a transportation system, we look at the demand, right? What is the demand? Where is the demand? And how that demand is distributed, right? And then we think of how to serve that demand, right? So the transportation system is developed in a way that we serve that demand in a cost-effective way. And another very important aspect about transportation, transport is multimodal at the system level, right? And that is also another important aspect of a transportation system, right? So we looked at the important components of a transportation system, right? Fixed facilities, roads, fixed facilities, flow entities, and controlling infrastructure and the users, right? And apart from that, another important aspect about transportation is that it is multimodal, right? So what do we mean by multimodal? Think of the simple act of going to work, right? Think of the simple act of going to work. Now, most of the time when we go to work, right, unless that we go from, driving our vehicle to work, so that is single mode. So from door to door, I use a automobile. But if we are using public transportation, right, we have to use multiple modes, right, to travel from home to work, right? We might have to walk from our residence to the nearest bus stop, and then we might take a bus to a nearby railway station. From the railway station, we might take the rail to cover the longer distance from my town to the city. And then from there, I might get into another bus and walk to my office, right? So transportation is mostly multimodal, right? That's the same way that we receive some goods that we consume, right? So they are manufactured at one location and they are transported in multiple modes, right? Until it reaches us at the as the last point of consumption, at the point of consumption. So it is multimodal at the system level. So no single mode can perform all the transport function efficiently, right? So within the system, right, transportation is provided as with a combination of modes, right? So the transportation system should facilitate this multimodal nature of transportation. Otherwise, it will not be sustainable. So you can see, so different modes have different strengths, cost structures, speeds, capacities, and environmental impacts. By combining modes in a coordinated way, the transport system achieves higher operational efficiency, lower costs, better service quality than any one mode could provide on its own, right? Okay. So now if I try to now, for example, let's say I try to travel from Sri Lanka, from my home to a conference in India, right? So if I try to drive to India, it is nearly impossible since there is no land connection, road connection from Sri Lanka to India right now. But it will be very long distance. Even if there is one connection, it will take a long time for me to drive from here to there, which is good if I enjoy driving, but it's not as efficient in terms of time consumed for travel, right? So I would travel from home to airport using a car, and from airport I take a flight to India, wherever the city I'm traveling, and likewise. So I'm choosing different modes in a way that I make my travel efficient, right? So longer distances, I need to travel using a faster mode. So aviation provides high speed, right? But aviation cannot reach my residence, right? So aviation is a high mobile mode of transportation, right? It's high in mobility, but very low in accessibility, right? So it cannot access individual destinations people want to travel, right? So therefore, aviation happens between specialized, like airport to airport, right? So accessibility is provided by other modes like walking, public transportation, and automobiles. So I need to combine all these transport modes together in order to achieve my goal of traveling to my destination efficiently. So therefore, transportation is multimodal at the system level. That's another very important thing. So we should not think of transport as a single mode, right? So we should be able to use multiple modes in planning our transportation systems or transportation networks and optimize our benefit. So as the same thing as little bit elaborated, right? Operational efficiency. So each mode is good at something different. Road, highly flexible, door-to-door services, best for short distances and small shipments, right? Road transport, as we know, they are very flexible, isn't it? Right? So you can have accessibility to a lot of locations, and residences can be accessed, right? Very flexible. Road transport, scheduling is very flexible. Accessibility is also very flexible, right? But road transport takes long time over long distances. You can't carry heavy loads over very long distances economically using road transport. It's good for shorter distances, right? What we say is, in order to provide accessibility, roads are very good, right? Then when you come to rail, what is the strength of rail? Rail is good for large volumes over very long distances, right? Large volumes over very long distances, rail performs very well. And so that's what these large countries with a lot of geographical space, like Canada, India, Australia, Russia, US, they have very well developed rail networks because they transport lot of freight over longer distances using rail transport, right? But in terms of, so that means rail is good in terms of mobility, right? You can transport large volumes fairly at a higher speed over longer distances economically using rail, right? But does it provide accessibility? Can you access rail wherever you want? Can you do it? You can't do it, isn't it? Right? Yeah. So you can only access rail at specific locations we call railway stations, right? We can only access the rail network at railway stations. And even if it is express services, we can't access that service at every station. There are only limited stations. So higher the mobility, less accessibility, less flexibility, right? Same with air transport, even high mobility, even higher mobility, but very less accessibility, right? So the idea is we need to pick the correct mode at the correct stage of the transport in order to achieve optimal benefit, right? So that's the idea of multimodal transportation. So therefore, transportation, in fact, becomes efficient when we view it as a multimodal system.
So excuse me, you told that that selecting correct mode, and what is the other factor to make
Correct,
to
yeah,
make
correct
it?
mode in terms of the correct phase. Like for example, if it is the line haul or the long distance that we want to transport, we use something like rail or shipping or air that provide economical travel over long distances. Now for example, if I'm sending jewelry or let's say electronic components or precision tools or precision parts like automobile parts to a factory in Japan, I should use air transport, because air transport provides that fast connectivity between longer distances. And then from my manufacturing plant to the airport, it has to go from road, right? So I need to use correct mode at the correct phase of my transportation process in order to achieve optimal benefit. So that the idea is to minimize generalized cost, right? So idea is to minimize generalized cost, right? So which I explained here, right? Now for example, let's say I'm going to ship something that is produced in Sri Lanka, maybe let's say furniture to a market in Australia, right? So the furniture is something that can have a very long inventory, may not be very expensive, so I can use shipping for that, right? So shipping can provide the long leg, right? The longer leg economically, right? So higher volumes can be transported using ships economically over very long distances, right? And then I use freight transportation from my manufacturing plant to the port, right? Which provides accessibility, right? And if what I'm manufacturing is precision electronic components or jewelry, something like that, which are very small in size compared to its value, right? And also their storage may be very expensive, right? Like these things are like, for example, automobile parts are used with just-in-time methods, processes. So they need to reach their manufacturing plants very fast, very quickly, with short lag time. So aviation should be used, right? Air transportation is most of the time used for that type of travel, for transportation. And Yeah, go
Excuse
ahead.
me, sir.
Yeah.
Sir, so then in the previous slide, there was a chart. So is it possible to no, next this chart, sir? So can we select that the multiple modes are there? So when that example, what is the most benefited way can we decided in based on this chart, sir? So can you brief regarding this chart, sir?
Yeah, this chart basically gives a general idea about how different transportation modes perform based on distance. Now, for example, road transport has minimum cost. Let's say the y-axis is transport cost per unit. X-axis is distance, right? Over short distances, road transport is more economical because you can transport smaller volumes to its final destination using the either first mile or the last mile, right? Using road transport because it's more accessible, right? And let's say if you take something like rail, right? Rail is more economical in the longer distances than road transport, but it is not so economical in the very short distances, right? Because rail uses very expensive to run trains, right? So and the infrastructure is also very expensive, right? So using trains for shorter distances is very expensive, right? But the cost can be distributed when you are transporting very heavy loads, right? Let's say 20 or 30 or maybe 50 truckloads of cargo over very long distances. It becomes very cheap compared to road transport at that phase, right? And then maritime transport is very economical over very long distances, right? That is between countries, right? Between countries, very long distances, maritime transport is very economical to carry very large loads, right? So the transportation cost is per unit. Per unit is minimum over very long distances.
Yes, sir. Thank you, sir.
Yeah.
I got it.
Yeah, I mean, the idea is trying to minimize the generalized cost, the total cost. Now, the point I want to make is this. Now, let's say I want to transport something from southern part of my country, let's say Gaul or somewhere like that, to the northern end, to Jaffna, right? Now, if I transport this load, freight, using road transport, yes, possible, right? I can load everything to a truck and take it from Gaul to Jaffna, okay? Now, instead of that, that is door-to-door shipping with only trucks is expensive and slow, right? Because road transport is not as fast as rail in certain instances. But if you use highways and all, road transportation also can be quite fast. But it is expensive. Still, it's expensive. But if you use rail, you can transport much heavier load, maybe 3 truckloads or maybe more than that, 20 or 30 truckloads of commodity from Gaul to Jaffna using train, right? Which will be at much lesser cost per unit, right? Much lesser cost per unit, right? But you will have some increase in handling cost, right? You may be transporting your goods from trucks to the nearby railway terminal where there need to be facilities for cargo handling, right? And cargo need to be unloaded from the trucks and loaded into flatbed or some other train compartments. Maybe it's containerized cargo. If it is containerized cargo, it's easy handling. But if it is loose cargo, it has to be loaded into cargo compartments of train carriages manually. So handling cost may be there, but then you make some savings in terms of the major distance, or the longer distance, or the distance between, let's say, Galle to Jaffna. And at the end of Jaffna, again, in order to reach your market, you might have to unload it from the rail transport or the rail train to trucks. So there is some handling at the origin end, at the destination end. So there is some time or the delay or additional cost of handling involved, right? But you make some saving in the in between the two regions, and the intercity travel, you make some a significant saving of transportation cost. So what you need to look at is the total cost. So if you make a total cost saving in terms of rail transport, that should be your best option, right? Rather than using road transport, right? But the reality in the Sri Lankan context is different. Most of our freight happens to go on road rather than rail, even though rail is very cost effective. That is because of reasons of inefficiency in the rail transportation system, right? The reliability of rail transport is low because of infrastructure deficiencies and the rolling stock deficiencies. The system is inefficient for freight transport. So given we have a very efficient rail freight system network, that will be a very good option to transport cargo throughout the country, right? So the idea is transportation is multimodal. In order to at the system level, transportation is multimodal to achieve optimal performance, right? Optimal performance, because otherwise single mode cannot perform or feasible for most of the travel requirements we have, right? Unless for very short travel, like going from home to work, using a car is obvious, a short travel we can do with a single mode, like using a car or taxi or something like that. But over longer distances, it becomes impossible. So multimodal systems allow the planner to allocate movement to the most cost-efficient mode at each stage. Any questions up to now? Anything you want to discuss? So we've been talking about transportation, its role in the society, right, and in the economy, what role it plays, right? And we talked about what is the public sector view and the private sector view about transportation, and how the two goals are different, and what is the interaction between these goals, especially in policy making, and to achieve sustainable transportation systems, operate them sustainably. And then we talked about transportation system. What is a transportation system? What are its main components, right? How they together make a transportation system, right? And then we talked about transportation as is multimodal at the system level. Why it needs to be multimodal, right? Because transportation at different scenarios job is to allocate our travel to the correct mode with the correct phase effect. Okay. Right. So now we are at transportation networks. Right. Right. So can you hear me clearly? I saw my connection was unstable.
Yes, sir, we can hear you.
All right. Okay. Right. And then the other very important thing about transportation is transportation systems are designed around the concept of a network, right? Transportation is viewed as a network system. There are other systems that are not networks also, right? Now, for example, if you take a manufacturing plant, right? If you take a manufacturing plant, it's not really a network, but it has one input and then there's one output. Raw materials are fed in from one or two locations, and then it goes through a manufacturing process, and it just comes out of the other end as a finished good, right? So it's just a sequence of activity. But transportation is a network system, right? It has multiple interactions within this network, right? So it's very easy to depict transportation as a network system, right? Where you have nodes and links, right? Always it's very easy, right, to depict transportation as a network. So therefore, and transportation is analyzed as a network, right? Transportation is analyzed as a network. Now, so transportation networks belongs to the wider category of spatial networks because their design and evolution are physically constrained, right? So they are spatial networks, right? They are transportation systems are designed around the concept of networks, and also they are called spatial networks, right? So these networks are spread out in space, right? Because the transportation, like let's say telecommunication or other networks, they are constrained by physical barriers, right? They are constrained by physical barriers or spatially constrained, like availability of land, geographic features, demand distribution, things like that. Transportation networks are constrained because of those geographic or the differences in spatial layout of things. Okay, so they are spatial networks. And also transportation networks are the outcome of a trade-off between the goal to connect as many locations as possible and cost and infrastructure development constraints. Now, for the third element, my example is think of a bus route. Think of a bus route. Now, if you think of a bus route, now somebody can think, I mean, why does the bus has to go on a specific route? Why can't it come and serve at my doorstep? Okay, so there are a lot of people around that wants to ride on the bus. The bus can come to each individual and take them on board and go. Why can't they do that? Can someone answer now? Why can't a bus can? Why do we have to go to a bus stop to get into a bus?
It is not for the fit. It is not fit for the purpose.
Doesn't fit for the purpose. Okay, why? What is the purpose? Purpose of public transport is to transport public. So why can't it come to your doorstep and collect everybody like a school van?
They have control routing system.
Okay. Okay, they have a control routing system. Why do they need to control the route?
Then the public, they know that these buses running on this road, so they need to reach to that place and get into the bus. So otherwise, they don't know which bus going which route at the time.
And the
It can
infrastructure.
Okay. Road infrastructures. Roads are there, and yeah, I mean, yeah, okay, correct. Now you see, our travel needs are both distributed spatially and temporally, isn't it? I want to travel at 8, you want to travel at 9, somebody else wants to travel at 7:30 in the morning, likewise, right? there is a temporal disparity or a mismatch or a variation of our travel needs, one thing. And the other thing is we are spatially dispersed also. My origin is at my residence somewhere else, and you are at another location, somebody else in a different location, likewise. Now, it's operationally extremely difficult or nearly impossible to match those temporal and spatial variations precisely, isn't it? I mean, it's engineering-wise, it's difficult, isn't it? I mean, how can you plan a bus route that reach everybody and whenever they require? It's like on-demand travel. Like you have on-demand travel. You call, you use one of these mobile apps and then you ask for a taxi to come. But that is only for yourself. If everybody else calls the same taxi, can you do your journey in time? You can't. And that won't be a taxi, but it has to be a big bus, right? And try to pick everybody like a school bus. You pick everyone and then go to your school and then you come back, you drop everybody at their residence and go. It takes a very long time. And so it is inefficient, right? So that is the trade-off. Transport networks are outcome of this trade-off between the goal to connect as many locations, right? So ideally, we should get transport wherever we need to travel, isn't it? Ideally. But it is not cost effective to provide that ideal service for entire public. Individual, yes, you can. You can call, you can call a taxi and travel whenever and wherever you want to go, like on-demand service, right? Very expensive, right? Very expensive. But for an individual person, that's all right. But for a public transport network, that's very ineffective, right? So you need to have a route that provide maximum coverage of your catchment, right? So we plan our bus route in a way that walking distances to the catchment is minimized, right? So we try to touch all the major demand points. Let's say there's a university, we go by the university. If there are schools, we try to go by the schools. If there are major government office complexes or commercial area, we try to touch those and go. Likewise, so we try to minimize our mismatch temporarily and spatially. Time-wise also, that's the same thing. So we schedule our buses 8 a.m., 8:15, 8:30, 8:45, and so on, right? And so people need to travel when the bus is available. So people will have a certain mismatch between their exact origin and destination and exact time of travel, right? So that's the inconvenience, right? So there is a trade-off, that inconvenience for the users and the economical travel. So that is balance. So every transport network is a trade-off resultant of that trade-off. And the location where you are in that trade-off can be different. Now, for example, for an on-demand taxi service, and for let's say you have a parcel delivery service like this, these riders we have these days, we call, let's say, Pick Me or Uber or something like that. We send a parcel, right? So that is a door-to-door service. So in that trade-off, the customer service is maximized, right? But the cost of the system is very high, right? So that is used for very urgent emergency situations. We use it because the value of getting that task done is very valuable than the amount we pay, right? But we don't do it on a day-to-day basis. No, that will be very expensive undertaking. So the different networks are at different locations of this trade-off. Did I make my point clear? Are there any questions? So let's say you have a manufacturing plant. Let's say some organization like Damro, right? So they have a manufacturing plant, and then they have their retail stores, and then they have the customers, right? So how do they manage their transport network, right? So they have various options, isn't it? You know, you can transport manufactured items from the factory directly to the doorstep of the customer, right? Or you can transport it, maybe they consolidate everything and maybe they have one truckload and transport it to a nearby warehouse. Or it may come through several distribution centers, let's say a major warehouse to a local distribution center and then to the customer residence, isn't it? So likewise, the way the network is developed is how they want to serve the customer. Right? So it would be very expensive to serve the customer from the factory to the customer doorstep, right? But if that's the case, they might want to do it, but different organizations have that trade-off set at different locations. And the network that different transportation systems operate is also different inherently, right? Now, for example, air transport networks work in a hub and spoke network, like mainly the legacy carriers, like Sri Lankan Airlines, Etihad, or mainly the flag carriers. They operate in a hub and spoke network, right? Because it's the economies of scale, because these legacy carriers operate hubs. Hubs in the sense they provide connectivity, right? Otherwise, you have the low-cost carriers that operate a point-to-point network, right? Because they don't have a hub. They do have their base airport, but technically they don't allow transfers from one destination to another through their hub airport. Whereas, let's say, Sri Lankan Airlines operate their hub at Bandaranaike International Airport. They operate their hub at BIA. So people that travel from India to Sri Lanka can transfer from Sri Lanka to Dubai through the airline, right? So they provide that connection, right? So that that connectivity is a characteristic of legacy carriers. So the hub and spoke system provide large number of connections with very less number of flight legs, right? So, right, because you are basically connecting through a hub. Otherwise, if you try to connect point to point, you know, like let's say now Sri Lankan Airlines can say they connect Mumbai to Dubai. So they don't fly from Mumbai to Dubai, but they fly from Mumbai to Colombo and Colombo to Dubai. So they connect Mumbai to Dubai through Colombo, right? So they can connect larger number of destinations through a single hub, right? Which is economical, right? Which is economical, and that's the business model of legacy carriers. That's the business model of legacy carriers. But the business model of low-cost carriers is different. So they don't operate in a hub and spoke network. They operate in a point-to-point network because their business model is low cost. Right? And then maritime networks operate in a different way. Maritime networks does not operate in a hub and spoke network. They kind of operate in loop, or we call trunk line networks. So they operate, let's say, east to west shipping lines. So these deep sea mega carriers, they travel on these, they only touch on major seaports, major transshipment ports, and then from those ports, feeders are connecting the origins and destinations. Like, for example, Colombo is a major transshipment port, and the Colombo gets larger vessels. And the other regional ports, let's say in South India and Pakistan, are connected by regional shipping lines. Right? So it's a different network. Logistical networks connecting manufacturing plants to distribution or the final consumers operate in a different network. Right? So likewise, rail networks, they have a different, now if you look at our national rail network, CGR, our rail network is a radial network. All the rail lines are concentrating in Colombo, Fort Railway Station, right? So it's a radial network, right? And then, yeah, so it's kind of a radial network. All the transfers happen at the centroid, center of the like Fort Railway Station. So that's the nature of a rail network, right? So because rail, you kind of have a line haul, you take large number of passengers over long distances, right? And then you have road networks. Yeah, you have major highways, and then the other. So there is a certain hierarchy. Now, if you look at our hierarchy, we have highways that are connecting regions like Southern Province to Colombo or the Western Province, and then Colombo to Central Province, Central Expressway. And then if we have Northern Expressway, northern part of the country. Likewise, it's regional connectivity is provided by expressways. And then inter-urban connectivity is provided by our A-class and the B-class road network. Like, let's say Colombo to, let's say within Western Province. Cities, let's say Colombo to Moratuwa or Colombo to Battaramulla is connected by our network of A-class and B-class roads that provide inter-urban travel, right, and suburban travel, right. So different transportation systems have different networks depending on their different characteristics. So the important thing to take away out of this slide is transportation systems are designed as network systems, right? Network systems that operate with nodes and links. Nodes represent intersections or terminals or interchanges, and the links represent roads and the flow and the connectivity between those nodes. It can be rail links, it can be roads, or it can be freight routes, anything like that. It can be these nodes can be warehouses and our retail stores. Now, for example, let's say some organization like Keels or Cargills, they have their warehouses. So they are warehouses, and then they have their retail stores. So their retail stores and the warehouses are the nodes, right? And how they are connected are the links, right? So they may have their suppliers like farmers and other suppliers of various commodities that they have in their retail stores. Maybe there can be a model where the retail stores are directly connected with the suppliers, right? And there may be some other network is retail stores are connected to the suppliers via distribution centers and warehouses. So the network is like that. So the nodes are the warehouses and the distribution centers and the retail stores, and the routing is the links, right? How they are connected. Any questions so far? So yeah, so just to connect why we are learning about transport networks are as I told you, transport systems are designed as network systems, right? So that's why we are learning about networks, transportation networks, right? So I want you to get the flow of my discussion today. So I started with the role of transportation and its role in the society and the economy, and why transportation is required. And then we talked about transportation systems, that is how transportation is supplied and consumed, right, within a transportation system. And transportation systems have different components, and then transportation systems are planned as network systems, right? They are evaluated and analyzed as network system. So that's why we are learning about transportation networks. I think I've been talking for about 1.5 hours now. Shall we take a short break?
Yes, sir.
Oh, yeah, okay, good. You have asked some questions. You want to discuss anything? So let's take a short break for about 10 minutes, right? So, no, let's say 5 minutes. 10 minutes is too long. We'll come back at 3:50, right? So this is now it is 3:40. We'll come at around 3:50. 3:45, sorry, 3:45. Okay, shall we resume the lecture? Right. Now, yeah, so we now know transportation systems are designed as network systems, as networks, right? So how we develop the network can be different from different context to context. So nodes and link structure. So transport networks inherently have a node and link structure, right? So the components are, of course, the links represent the linear features providing for movement, such as highways, rail lines, right? And also, as I told you, the links does not have to be exactly the roads, right? They can be the routes. Now, for example, if there is a warehouse and then from the warehouse it goes to a regional distribution center, that connectivity between the warehouse and the regional distribution center is a link. And of course, the travel happens on the road, but if that link is that connectivity or the movement between the warehouse and the regional distribution center. And then if there is another satellite distribution center in the city, then it can be connected. And then for any emergency or any special deliveries, if there is a link between the manufacturing plant and the satellite distribution center, we can have a link. So that means there is a link, there is a freight flow between those nodes, right? It doesn't really mean the road itself, but there is a freight flow, right? So that is what we mean by the link, right? Nodes are the places where the consolidation happens or the transition happens or the transshipment happens, like a distribution center or a satellite warehouse or a manufacturing plant or something like that. And the link is the flow between those transitions, right? Or interchanges. And if it is like a transit network, so if you take a transit network, the nodes are the bus terminals. Let's say the bus network. Let's say the Western Province public transportation or the bus transportation network. So we have, so if you take the public transportation system, bus transportation system in the country, National Transportation Commission, we call NTC, oversee the interprovincial transportation, right? Transport happen between across provincial boundaries, right? So they are responsible for regulating those buses and giving bus routes and things like that, right? So that's one transportation network. And then the provinces have the local transportation authorities, so like Western Province Transportation Authority, Central Province Transportation Authority. So they are responsible for the transportation within the province. All the bus routes and things are, regulations are done by that transportation authority. So if you take, let's say, the Western Province Transportation Network, bus transportation network, you have all the bus routes. And every bus route is connected to a bus terminal, right? So bus travel happen from bus terminal to bus terminal, right? So then the bus terminals are the nodes. Bus routes are the links. Of course, the bus travel along a road, to make that clear differentiation. It doesn't have to be the road. Sometimes we physically identify the road as the link, but sometimes it is the route, right? Not exactly the road, but we depict the flow of passengers or buses in that route. Okay, so the links are the bus routes and the nodes are the bus terminals. And also the nodes also can be the bus stops. Bus stops are also nodes where the passengers can get into the buses. So the bus stops are the nodes and the terminals, and the links are the bus routes. Right? So nodes represent intersections, terminals, junctions, right? Ports, airports, right? Things like that. Okay, now it's clear that the links are that provides the flow. Now if I ask you a very simple question, now what is the if we take the rail network, rail stations, we have the railway stations. We have the railway stations. If you take the coastal line, or if you take the main line going to Kandy, you have the railway stations. So what is the, so those are the nodes. Of course, the rail tracks or the links provide the train to travel between the stations. What is the main role played by the railway stations or the nodes? What is the role or the function of these nodes in a transportation network? That's my general question. So what is the role played by the nodes? What is the main function that they provide?
Providing accessibility
Providing accessibility to what?
To the get into the trains.
Okay, good.
And also bus.
Yeah, go ahead. There was another answer.
They are facilitating to continue the rail transportation.
Okay, good. So as one of you said, that the nodes are the places where you can access that particular network, isn't it? Like airport is the place that you can do the transaction with the air transport network. Right? Without airports, you can't access the air transport network. So there won't be an air transport network without airports. And if you don't have railway stations, you can't access the railway network. So the access points to the network is the nodes. And also the nodes provides another very important function. What is that? That is the access point. Because of it is the access point, there is another very important function it provides. It performs, in fact. What is that?
It's facilitate to link other nodes also, sir?
Yeah, it facilitates to link other nodes, yeah, of course. So in the network, you have nodes. Nodes provide connectivity with other nodes. That is performed by the links, right? So the nodes are there. Links are connecting nodes with multiple nodes with each other, right? So what is the, now we all agree, now we all discuss that nodes provide access to the network. Now, if you have a freight transport network, you have your various distribution centers and in your warehouses. It is from the warehouse that you put all the cargo to your freight trucks, and then you transport in your transportation network, right? Let's say, as I told you, now let's see, for some retailer like Keels, as I know, so they have one central warehouse somewhere in Keravalapitia, right? And everything, all the supplies comes to that central warehouse, and from that warehouse, various types of trucks are sent out to all the retail stores in the country. Maybe they have some other warehouses in other faraway regions. I don't know, but as far as I know, they have one big warehouse in Keravalapitia. From there, they connect most of their retail stores. So now, in order to access that network, goods should come to that warehouse. So that warehouse acts as a place of accessing that network. So, and now, in order for the goods to, from the supplier to the freight transportation network, what is happening within that warehouse? So does the goods directly, like cross-docking? If it is cross-docking, yes, you have cargo from one truck directly taken into another truck, right? But that's kind of cross-docking. So there is no real but there is some transfer happening. But in a warehouse, what other things happen to the cargo? You have mode transition, isn't it? Now, let's say in a railway station, you come by bus and then you need to get into a rail network. So from bus to rail, there is a mode transition, right? So there should be a bus stop. So we need to provide that mode transition. We need to facilitate that. If the network is to access a wider catchment area, otherwise, if you don't have a bus stop nearby the rail network, what happens? We have some examples like that. Now, if you what I personally know, some railway stations nearby, let's say Mount Lavinia and Ratmalana and those areas, they are a little bit away from the Gold Road, right? So like if you don't have good connectivity with the bus network that travels on the Gold Road that provide good accessibility to the inland locations, there won't be much demand for the rail network that is going along the coastline, isn't it? It will be only the residents that are living nearby the railway station that can access the railway station. Right? So if you need to have a good bus stop, and the bus routes also should go through the railway terminal, should touch the railway terminal, there should be a good, feeding mechanism from the bus transport network to the rail transport network. And if you take an airport, you need to have good mode transition. Let's say you go by your car, and then you need to have a very safe and smooth transition from your car to the aircraft. You can't just hop out of your automobile and hop into an aircraft. You can't do that. An aircraft is a different type of a vessel, and an automobile is a different type of a vessel. So there need to be some transition that need to happen for administrative purposes as well as for safety reasons, to take a passenger from a road transport mode to an air transport. So that transition is provided by the airport or the node, right? And the same thing for a rail network also. So you can't just, from your motorcycle or from the three-wheeler or from the bus, I can't directly get into the train. So the railway station is built in a way that I can get out of the car. There may be a carport or a car park. I can stop it there. I can have a safe walk from the car park to the terminal. Railway station has a platform where it is a raised area, and it provides seamless connection with the rail platform or the train platform. So that transition is provided. So this is what we call the mode transition, right? So these nodes are a place of interchange, right? Modal interchange, isn't it? Right? So it provides accessibility, yes. While providing accessibility, it acts as a modal interchange, right? So that accessibility is to transfer from different modes, right? So highly accessible nodes in a transport network is nodes that have transition, that accommodates transition from multiple modes, right? So you should, in the context of passenger transport, and in the context of freight transport is also like that. Now, if you are, as in the previous example, if you are transporting cargo from Goa to Jaffna, I need to have a good cargo terminal or cargo facilities at the railway station for me to transfer my cargo from my freight truck to the rail service or the train, isn't it? Right? If it is containerized cargo, there should be a hoist where the container can be picked up from the truck and loaded to the flatbed on the train. Or if it is other cargo, there need to be good equipment and staff to transfer it. If that mode transition is not there, then you can't do the transfer. Right? So it is inaccessible basically. Right? So that accessibility, the level of accessibility is determined by the facilitation for that mode transition. Now, in a freight network also this can happen. Now, in a 2-level or a 3-level freight network, that you have your end customers in the city and your manufacturing plants are located ideally outstations in out of the city. And so what is produced come through a series of warehouses and distribution centers to the final customer. And then maybe there is distribution centers located nearby to the city, and you get large trucks transporting large volumes from your manufacturing plants and from your suppliers to those warehouses or distribution centers, and they need to be deconsolidated and sorted and loaded to smaller city travel vehicles, maybe vans or cars or bicycles or whatever, that provides distribution within the city, right? So this transition have to be done seamlessly within those centers, and that's where they become accessible, right? So that's the idea. So the nodes are a place of mode transition, right? And also it's a place of accessibility to the network.
Sir, is there any difficulty in Sri Lanka to develop railways as that transportation of goods? That means that you told that we can transport containers via railway trains, right?
Yeah.
But
I think as I know, there is already, I think INSEE is doing that. And they are doing that, but some CPC is doing that to a certain extent. They transport fuel using trains, but the mode share for freight transport in trains is very low in Sri Lanka, very low. I think the main reason for that is, one thing, there is a lot of competition from road transport, right? And the other problem is the facilitation by the rail operator, and the facilities available and the reliability is not very good. And I think because of deficiencies in locomotives with the Sri Lanka Railways, they give priority to passenger transportation. And if and when available, they provide locomotives to freight transport. So freight transportation is not so reliable, and there can be delays for freight transport, cancellation of freight trains for those reasons. And therefore, freight transportation is naturally not choosing rail. The potential is there. Of course, the potential is there if that is facilitated, right?
yes, sir. Actually, if such kind of thing can be implemented, we can reduce the road accidents also. If we take that building materials like sands, if we can transport those via railway tracks.
Yes. One thing is um, rail connectivity with the demand points, right? So let's say, as you said, okay, but building material like sand and cement, things like that, steel, can be transported by rail. And also then, as I told you, when we are using such a mode, they provide cost efficiency for long distances, carrying heavy loads. Large volumes need to be transported over longer distances, right? That's one requirement. And the other requirement is handling. So you need to have specialized facilities to handle cargo at origin transfer and the destination transfer, right? So they need to be facilitated. Otherwise, the whole purpose is lost, right? So containerization of cargo is one good way of reducing handling costs, right? Containerization. So, containerized cargo, I think that's what INSEE is doing. So they are containerizing cement, and then these container boxes are transported, as I know. I mean, if somebody has some experience and working in that sector, you can input to this discussion. If we can transport containerized cargo using rail, which is very good, then you need to have good connectivity between the demand points, right? Because our rail network it connects all provinces, most of the provinces of the country. Yes, it connects most of the provinces of the country, and then the cargo or the freight it transports should be distributed to the final points of consumption efficiently. Right? So that's the requirement. That's the requirement. From the sources, it need to be transported to the rail network. There need to be good connectivity between the rail network and the sources. And then there need to be good connectivity between the consumption points and the rail network. Right? So that's one of the challenges in Sri Lanka, right? Because our road network provides good accessibility to majority of the locations, right? So when the highway network is also developed, railway will have a lot of competition because road network will be then capable of giving high level of mobility over long distances. Interprovincial connectivity will be improved with the highway network. With that, these freight transportation costs will reduce further. Well, and also but still trains can do a very good job in transporting large volumes over longer distances, right? That's where the benefit is, right? So we should be able to transport large volumes over long distances. So it can work for building materials, especially, right? Where Western province is a large consumer of building material because of a lot of economic activity happening in Western province, and they are sourced from faraway locations in the country. So those large volumes can be brought in by train. Yes, of course. One of the reasons that it cannot happen the way it is because of specific facilities are not available. Then there should be some government involvement in getting it done, and also the railway operator should be able to run a very reliable network. Those are the challenges we have. Otherwise, it's possible. Yeah, and also another feature of transportation systems networks is its layered or hierarchical nature, right? Now, this is especially in freight transport, right? As I told you now, in freight transport, you have 3-layer or 2-layer networks, right? Now, for example, in literature, they come as echelons, right? First echelon, second echelon. So they're like the level, right? So the first echelon is the long haul transport, maybe from your suppliers, your sources, your manufacturing plant to the regional warehouse. Large truckloads come. Those things can be done by rail, right? Where large volumes transported over long distances can supply to regional warehouses that are located in the suburbs, in urban areas, maybe Kandy or Colombo or Southern Galle, where those are the major cities, major urban area, right? So then the second echelon is then from those warehouses, they are deconsolidated, and they are broken and sorted and transported to other distribution centers within the urban area, right? So that happens using smaller trucks, right, or city freighters, right? And from there, like if there is a third echelon, right, from the second echelon, if from the distribution centers, they reach the consumers. They are, kind of going to the retailers, retail stores, or the small shops, or distributed to the customer. That happens on small trucks, right? So the network is kind of in two layers: the first echelon, second echelon, right? And the facilities and the vessels or the vehicles used are different to provide the cost efficiency and the effectiveness. Now, you can't take big trucks in the city, it's difficult. So you can't find parking places, you can't do loading and unloading, you can't reach all their customer locations using large trucks. So large trucks can come into large warehouses that are located outside the city, that have big parking areas and docking space available. And then to reach the city center or the urban areas, urban retail stores, you need small trucks or pickup trucks or smaller vehicles that can provide quick connectivity between those regional distribution centers with the customer. Second echelon, right? I tried to develop an example based on the Keel supermarket chain in Sri Lanka. So where they have a hub and spoke network. So they have this Keravalapitia warehouse as their major warehouse. From that warehouse, they have an outbound fleet that goes into their retail stores, right? So they have different, truck, frozen goods, chilled goods, and dry goods. They go in different trucks, and they serve basically all their warehouses or all their retail stores from the central warehouse. So central warehouse is like a hub, and that hub gets the inbound loads from your suppliers, the manufacturers, importer, whatever. Everything comes from the suppliers to the warehouse, and the warehouse provides storage and the sorting and packaging. And then from there, they are distributed using trucks to all their island-wide retail network, right? Hub and spoke. And in contrast to that, Cargill's supermarket chain operates with a different structure. They are like a multi-echelon, right? So Keel's has a single echelon, single level, right? They have one warehouse. From the warehouse, every retail store is supplied. Where Cargill's, as I learned from available sources, is multi-echelon. So they have their regional warehouses, like major warehouses, and then they have their district level warehouses where goods are supplied to the retail stores using those. And then they have primary collection centers. So they have some collection centers that are close to their farmers. So they have some program that they collect local produce. And from those collection centers, goods are fed into their major distribution centers. And from their major distribution centers, then goods go to the regional distribution centers, and from there to their retail stores. So it's kind of a multi-echelon network they operate, as opposed to what a supermarket chain like Cargill, Keel's are operating. So their optimals are at different locations. So that's why they operated with that. So what I just wanted to depict is the different networks operated by different organizations in their transportation system.
So as we are in a small country, do we need such a transportation system with many nodes? Because Keels, we can manage everything with the one node.
Yes, well, that depends on how quickly you want to respond to your customer needs, isn't it? Now, if how quickly you want to respond to your customer needs, as well as how you want to optimize your distribution network. Now, if you have one mega distribution center and then you schedule your fleets, it's kind of vulnerable to any disruption in your major warehouse. Your entire network is dependent on it, right? So one issue is that. So if that warehouse has any disruption, maybe an emergency fire or something like that, so your entire distribution network is affected. But if you have a multi-echelon system, you are more decentralized. So your part of your network still can operate if any disruption happen in any other location in your network, right? That's one thing. Right? And the other thing is your cost of your transportation, right? Now, which I exactly don't know which one is better than the other one. Now, an organization like Cargill's, as I know, they have a mechanism of sourcing their produce directly from the farmers, right? So therefore, they have their collection centers in locations nearby to the crops are produced, right?
Yes, sir. It could be
Right.
the reason. Yeah.
Right. So then
Lovely.
they consolidate those at those regional collection centers. From those collection centers, they come to their level 1 distribution centers somewhere like Kadawatha and Makumbura, where packaging and some preliminary processing happens, right? And from there, they may transport. The other thing is this. Now, when you have this distribution center hierarchy, you do your transportation in large volumes, right? So you can still consolidate large volumes very close to your final demand point, right? Because you do consolidation very towards very up to very close to your final retail store. But Keels, you are sending trucks to individual retail stores, or at least to on a particular route, right? So you need to have a large fleet of trucks, right? You need to have a large fleet of trucks to do that operation. Of course, your flexibility is high. Your flexibility is high, but you need to have a large fleet because you are feeding each and every retail store from a central warehouse. Now, in this case, you are transporting most of your goods between distribution centers. So that means you can achieve economies of scale by maintaining large volumes between these distribution centers. So it is at the last stage, you break it into smaller consignments and send it to your retail stores. Right? So different strategies depending on the business models that they operate. Okay, evaluation perspectives. So I'll just quickly jump over these things. So I'm having only 30 minutes left. Right now, how to evaluate transportation performance, transportation system performance? There are different ways that we can do this, right? One of the primary ways, I'm not going to talk about everything, is to evaluate transport systems is mobility and accessibility. Right? Let me first get to accessibility. Right? So accessibility is the most important thing. Right? Why accessibility is important? Because the essence of transportation is access. Right? I need to access. Let's say I'm hungry. I want to eat a pizza. I want to access a pizza. Either I need to go to a pizza restaurant or a pizza should come to me. Right? That's my primary need. I want to go to work. I need to access my workplace. Right? So the primary purpose of transportation system is to provide that accessibility, right? People need to access their workplaces, or basically markets need to be accessed, right? Goods need to be accessed to their customers, right? Or customers, either way, customers should be able to access the goods, or goods should be able to get to the customer, whatever. This accessibility is most important, right? Now, how to provide this accessibility is the next question, right? Now, if you try to focus, so we call like accessibility is provided by connectivity and mobility. Accessibility can be considered as a function of connectivity, right, and mobility, right? So what is connectivity? Connectivity is this. Connectivity is how strongly you are connected, right? How strongly you are connected. Now, look at the keels and cargills. Keels have a hub and spoke. Your retail stores are directly connected with the one mega warehouse. If that node is taken out, you don't have connectivity. You are not connected. You can't reach, the goods cannot reach from the supplier to the retail store if that node is gone, right? But the Cargill's case, a particular retail store can be connected through several distribution centers. So there is more connectivity there, right? One retail store is connected to the supplier through several distribution centers, right? So you have more connectivity, right? So connectivity is how well you are connected, right? I mean, we don't care really whether the connection is good or bad, right? Let's say I want to go from my residence to University of Moratuwa. I should have several routes that I can reach, right? I should be able to go via Nugegoda, or I should be able to go via maybe Kottava or whatever, maybe some other place. Likewise, you know, I'm residing in Battaramulla, so I should be able to reach Moratuwa by multiple routes, right? More the routes that I can connect independently to the destination, higher the connectivity. So that's what you can see in these diagrams below, right? So we have the same number of nodes. You can see same number of nodes and different level of connectivity. So going from A to D, the connectivity is increasing, right? So you can see the connectivity is increasing with the density of links, right? That is the configuration of the network, right? And so that's one part of accessibility. So your accessibility is high when you're connected, well connected, right? You say you're centrally located, you are very connected. So your accessibility is high. So you provide your warehouse, you provide your retail store, you provide your organization well connected to your market, right? So you have several routes of access, right? So if one route is taken out, maybe due to congestion or due to some other disruption, there should be other routes that the market can be reached by your warehouse or by your retail store. And then the other factor of accessibility is mobility. What is mobility? Mobility is okay, you have your links, but how fast you can travel within those links, right? Right. Having a link is no use if you can't travel along that link. You know, now let's say, now think about Colombo city during the rush hour, right? Colombo city during the rush hour. Let's say Gaul Road. Let's say somewhere around from Gaul Road around Bambalapitiya or somewhere like that. Traffic congestion is high, very high during the peak office hours, right? You have good connectivity. The places are very well connected. Everything is nearby. Office complexes are nearby, very well connected. But do you have good mobility? Can you go from one place to another very easily? Difficult, right? Because roads are blocked. You have very low mobility, right? Okay. So these two, mobility is how fast you can travel. But faster you can travel, accessibility reduces, right? That's the trade-off, right? That's the trade-off. So mobility is the ability you can transport larger volumes with higher speed. Now, for example, if you can look at the expressway network of the country. Expressway network provide high mobile connectivity between provinces, right? Southern province, Western province, the intercity, Galle to Colombo, right? And when we have our central expressway done, we can have central province, central of the country connected with the Western province with the highway. Can travel fast. Large volumes can be transported faster. High mobility, that is the meaning of high mobility. But is it accessible? Can you access the highway very easily? Very difficult, because that's the trade-off. So higher the mobility, lower the accessibility. If you increase accessibility, lesser the mobility. So that is what has happened on places like Galle Road and any other arterial road in the country. Everything is located along the road, the shops and the residences and everything, right? You do U-turns and everything, everything is there. All the activities happen along the road, right? So you can't, your mobility is very low. You can't travel very fast, right? Because vehicles are entering the road from shops and residences and various by roads. Everything is connected to the major roads, right? If you take Galle Road, for example, that's the problem, right? So, but the highway, it is not connected to all the activities around it. So it is only the accessibility only given at specific locations. Accessibility is low, mobility is high, right? So in an efficient transportation system, so these accessibility in mobility should be provided in optimally for any specific origin and a destination need to be connected efficiently, right? So that's why we have the central expressway network now providing that mobility part. Otherwise, before the central expressway, the purpose of the Galle Road, something like Galle Road A2 or A1, right, is to connect Colombo with other cities like Galle or Kandy, right? So the purpose of that is to provide high mobility, but the purpose is lost because it is providing access more than expected. Access is not regulated, right? Accessibility is not regulated because all the land along these roads are provided access from the main road. So a lot of activity is happening, and that disturbs through traffic, and the mobility is disturbed, right? So you don't achieve that goal, right? But you need accessibility also. But if you have only expressway network, how can you reach your final destination? So you need to have a correct balance of mobility and accessibility in a transportation network in order to achieve the objectives optimally. Like the same thing for a freight network also. If you only have your major freight, like if you try to transport goods from your manufacturing plants or warehouses in large trucks right down to your final consumption point, it's not going to work. It's not very efficient. So you should bring your large trucks fast in high volumes, like high mobility links should be from your major warehouses to your regional distribution centers, or from your manufacturing plants to your distribution centers or the warehouses, and from your distribution centers to your final consumption point. That's the access part, the last mile. Last mile should focus on accessibility rather than mobility, right? It should be able to access individual customers quickly, right? So that's the idea that I want to give in terms of mobility and accessibility. So these are the variables we use to evaluate transportation networks: traffic, connectivity, mobility, and accessibility. In fact, accessibility is the most important, and accessibility is considered as a function of connectivity and mobility. Okay, that's what you need to take away. This is the most important part. And of course, transportation has its negative externalities. So we've been talking about transportation and its systems, networks, and their main performance indicators like accessibility and mobility. And then they are also evaluated in terms of their negative externalities, right? What are the negative externalities of transportation? Congestion, accidents, energy dependence, and pollution, right? And as one of you correctly suggested earlier, one of the reasons we should transfer heavy goods vehicles or the freight transport vehicles to train is a lot of the accidents are reported due to these trucks, which is not one of the reasons is that the safety is not regulated in this goods transport sector, but there are organizations who do it very well now as I know, like companies like Unilever's. I mean, there may be other companies, I just don't want to single out one, but that is what I know already, where they transport their goods to retail stores throughout the country, and they have a good mechanism of regulating safety, and they have an operating center to control their freight transport network, right? They have an entire staff, and they use technology like AI, facial recognition. They have CCTV cameras to their trucks. They monitor the driver condition. They monitor the truck condition. All of that is monitored, and truck driver health conditions. Everything is monitored in order to make sure that the safety is maintained, right? Because it's very costly for a transport service to get into accidents and disruptions, right? You lose your entire cargo consignment, your cargo is delayed, you lose your customer satisfaction, everything is lost, right? So investment in maintaining high service standard or high safety levels is paid off when you are reducing accidents, right? So that's what companies like that are doing. Yeah. So accident is one thing like that, and energy dependence, right? Now you may be observing a trend of electrifying freight transport, right? A lot of organizations are thinking of using electric trucks for the freight transportation. So this is to mainly to avoid depending on fossil fuels, right? That is towards energy security, right? One of the byproducts of that is reducing emissions, right? Given that you use renewable energy sources to charge your batteries like solar and wind. So energy dependence, pollution, air and sound pollution, water pollution are negative externalities where transportation systems try to minimize, right? So these days, these externalities play a big role in defining transportation networks, network configurations, operations, type of vehicles used, type of routing used, depends on these externalities, trying to minimize these externalities, right? Right. So transport and logistics cost, yes, transportation is a big cost component of logistics operations. So what I wanted to highlight here is transport plays a big role in the whole logistics process, right? Transportation costs represent about 50 to 60% of total logistic costs for most production firms. So transportation is very important. So planning the transportation component in your logistics operation is very important, right? In terms of minimizing its negative externalities and as well as the direct cost. So transportation in the whole supply chain. So if you take supply chain management, transportation sits inside logistics, right? So supply chain is a broader process which connects the supplier to the final point of consumption, right? So it encompasses all the activities and processes associated with flow and transformation of goods from raw material stage through to the end user, and it involves both information, financial flow, and goods flow. Everything is managed under supply chain management, and logistics is a component of supply chain management, and transportation is within the logistics. So transportation facilitates the logistics. So logistics is basically making sure the people and the goods are at the right place at the right time when they are needed. As you know, remember what we talked about, the place utility and time utility. That's the whole objective of logistics, and transportation facilitates that. So that's where transportation sits in the whole supply chain process, right? This I already discussed about these points, that different modes of transportation have different characteristics, and they have to be used optimally depending on the business that we are in order to achieve the best, in order to minimize the cost of transport. Basically, not to say minimizing the cost, maximizing the benefit, maximizing the efficiency and effectiveness of your transportation operation. So maximizing your efficiency can include minimizing your cost and minimizing your delay, travel time, and things like that, right? See, that's why I said maximizing your efficiency. So when you maximize your efficiency, doesn't mean that you minimize your cost always. The cost, like minimizing your cost and minimizing your travel time and delays are conflicting sometimes. So because if you try to minimize your travel time, you can increase your cost as well. That's why I said, yeah, I should say optimizing your efficiency, right? Optimizing. So optimization is trying to achieve that point where you maximize some aspect by subjecting to a certain set of constraints. Yeah, so all of this talks about different characteristics of transportation modes, right, which I don't want to pay a lot of attention to here, which you can go through the note and get into that. So what I wanted to focus specifically within the available time is this. Yeah, the use of mathematical models, analytical models for decision making in transportation. Of course, right now, these models, these concepts were developed long time ago, and still they are in research and still they are being developed. But this day and age, implementing these models are very easy with the availability of a lot of AI platforms are there. They provide very convenient application of these models, advanced versions of these models to your day-to-day operations, right? But you should know where to find them. You should know the existence of them and what they are capable of, right? So, so I just want to focus a little bit more onto that within the remaining time, right? So one of the available models for us to evaluate logistics networks or transportation networks is what we call, there is a broad set of mathematical, a stream of mathematics called operations research, right? Operations research involves a lot of things related to optimizing certain operations related to manufacturing, transportation, and it involves simulation modeling, machine learning models, things like that. So they all fall under the big umbrella of operations research. So within operations research methods, we have a separate class of mathematical problems that we called network optimization problems. So most of the network optimization problems, their formulations can be applied to solving transportation problems, right? One of them is what I have here right now is a capacitated vehicle routing problem. So this vehicle routing problem is something where, let's say you have a warehouse or distribution center, and then you have your demand points located around the city, and each demand point has a specific demand, and you need to know how to assign your fleet of vehicles to specific routes that minimizes your total transportation cost. This is called the capacitated vehicle routing problem. By formulating your problem according to this mathematical formulation, we can get the solution in a way that how each vehicle have to be assigned to specific routes in a way that you minimize your transportation cost, right? I'll give you a very brief example. I think I'll just quickly stop sharing my slides. I'll just bring in an Excel sheet here. Just give me a moment. Yeah, sorry about the delay. Can you see this Excel file I have on screen? Hello, can you see the screen I'm sharing?
Yes, sir.
Yes.
It is.
Yeah. So this is the example I just want to show you in terms of capacity-led routing problem. Now, this is a case where you have, this is in a dairy industry. Now, this is some activity that I've done. And in this task, what we had to do was, so there are these blue dots you can see here represents the locations of different farmers having milk collected from their farms, and they have different volumes that they have collected. So this is in the other way, this is like your demand points. You have your distribution center where it is orange dot, and then the other blue dots can be your demand points. And then they have these different demands. Maybe retail stores or maybe other stores, they have daily orders placed. And then you have different vehicles, right? Different vehicles with different capacities, right? They have different capacities, how much that they can carry. And each one of the vehicles have a different operating cost, right? Some vehicles can carry larger volumes and their operating cost per kilometer can be per unit can be less, right? So their volumes larger, their costs, their volumes different, their operating costs are different, right? So now my task is, now how am I going to assign these different vehicles to this network in a way that I minimize my total transportation cost of reaching each one of these customers and delivering the goods. Or in my case here is basically going to each one of these farmers and collecting their milk and come to the final collection point, right? So this is solved using the capacitated vehicle routing problem, because each vehicle has a fixed capacity. I cannot exceed the capacity within a particular route, and also they have specific operating costs. So I need to assign them in a way that the total cost is minimized, right? So this is run using a solver, an algorithm. So this is, I've built it in Excel, but this is solved using a solver called Open Solver, because this is a large problem and it cannot be solved using Excel solver, right? But, can be solved more, quickly with a specific solver. Finally, I get the result in terms of the particular route that I should follow for each with each vehicle, right? Right. So I hope that results available here, but may not be as I'm opening an older file. Unfortunately, it's not. But anyway, I hope you got the idea. It's basically to identify how many routes are served by, let's say, Bolero pickup truck, how many routes are served by the Demo Batta, and how many routes are served by the three-wheeler, right? So that's how it is done, right? So let's going back to my presentation. Right, so that is the capacitated vehicle routing problem, and there are other such mathematical problems called transportation problem itself. The name itself is there. It is also a similar type of problem formulation where you have multiple supply points like Q1, Q2, Q3, and then you have multiple distribution centers, right? And also some of them can be distribution centers and some of them can be your customers. And you can decide in order to minimize your total transportation cost, which warehouse or which distribution center should be served by which manufacturing plant, and whether certain customers can be served directly from the manufacturing plant without going through a distribution center, right? So this is a single echelon problem But there is one advanced problem called the transshipment problem. In the transshipment problem, you can have your customers after your warehouses. Now, in this problem formulation, you have the manufacturing plants and the distribution centers. That's only two levels, one level. And the second level can be your customers. And then we can decide what is the configuration that minimizes your transport cost, which customers have to be served through what distribution center, and which customers have to be served directly from the manufacturing plant. Right? So these models can be used for planning your transportation operation. And then you can fine tune using the field knowledge and your experience at the operational level, at the operational point. Right. Yeah. So that's basically what I have left to talk about. This is kind of the application of that transportation problem in a very abstract form, right? I wish I had some time to show you another few other applications of these optimization models that we have applied in real applications, but don't have time remaining. So yeah, so that's it. That's all I have to talk with you. Any questions from your end in terms of the main concepts we have discussed today?
Sir, excuse me, sir. Sir, what
Yeah.
kind of software or application can be used for this calculation work? Are there any examples? Sir?
For very simple, let's say for the routing problem, if the nodes are, let's say, not more than 5, you can use Excel solver. That's the limit. If your nodes are typically more than 60 or 70, the problem becomes extremely large. You have to use proprietary software to model the problem and generate solutions, right? You can model them in open source software like Python, also can be used, and they have libraries for these algorithms. Or you can use any commercial software packages to solve them, right? Yeah, and I think these days there are you can use AI platforms also that can solve these, but they cannot solve larger problems exactly. But if the problems are very small, these AI platforms also can solve them. But if the problems are large, they cannot solve them. We have to use proprietary software for them.
Yes, thank you, sir. Okay. So thank you very much, sir.
Okay, you're welcome. Any other questions?
We discussed the components of a transport system. Then we talked about links and nodes.
Yeah.
Sir, but we didn't discuss about hubs.
Yeah, good question. Hubs in the sense are the nodes themselves. Hubs is in the transportation context. Let's yeah. So let's take some example like this, right? So the distribution center you see in the middle can be considered as a hub, right? So hub in transportation context have different meanings or different functions depending on what operation you are doing. Now, for example, let's say what Sri Lankan Airlines are doing. Sri Lankan Airlines operate Bandaranaike International Airport as their hub, right? So the definition or the term hub is given to a particular facility by the operator, by the transport operator. It is not an attribute. It's not something achieved by the operator. It's like not the facility operator. Now, let's say Bandaranaike International Airport, BIA, they cannot call themselves a hub unless an airport is using it as a hub. Sri Lankan Airlines is using BIA as a hub because they facilitate connections within their network at BIA. Right now, for example, Sri Lankan Airlines have their fleet stationed at BIA, and all their operations originate at BIA and reach the various destinations like Singapore, China, Australia, UK, Dubai, Middle East, and various other places. Right, and they all come back to BIA. Right, or a passenger who is going to India from Melbourne can come from Sri Lankan Airlines flight coming from Melbourne to Colombo. At BIA, they can transfer to a flight to Mumbai. Right, so that transfer is provided at BIA. So it is Sri Lankan Airlines is choosing where they use as their hub. Usually, the national airlines use a major airport as their hub. Right, but now let's say Emirates. Emirates is operating at Dubai International Airport as their hub, and they use BIA as one of their feeders. Therefore, for the Emirates airline, BIA is a feeder. For Sri Lankan Airlines, BIA is a hub. Right? So therefore, this hub is a matter of, it's a transport operation. Right? So usually a hub is a place of activity concentration. Now, in the freight distribution context, a distribution center is usually a hub where you have your larger flows coming in from your suppliers or from your manufacturing plant in large volumes. They come into your distribution center, and then they get sorted, and then they get transported to smaller trucks and go to your final retail outlets. So therefore, distribution center is a hub, right, where it connects your suppliers with your buyers or retail stores. Because otherwise, if your retail store is going to get individual shipments from your suppliers, it's very it's more flexible, but expensive, right? Because you don't get full truckloads. You have to, because each retail store has a smaller demand, right, from each supplier, right? Because if you get all your retail stores on your right hand side have let's say I'm ordering something from soft drink manufacturer, right? One supplier is a soft drink manufacturer, right? So all my retail stores have their requirement or demand for soft drinks, and so one big truckload of soft drinks can come to the distribution center and then be consolidated and sorted and distributed to your retail stores. Otherwise, if your soft drink manufacturer is going to supply individual retail stores, that's going to be expensive. Right? So your distribution center is kind of a transshipment point, right? So it's a hub, right? So in that freight operation, that's the activity of a hub. Right? Now, we call, let's say, Makumbura multimodal hub. That's the term we use, right? So a Makumbura multimodal hub is a place where multiple transport networks are connected. So that is also a hub, right? Where transfers happen. So usually in transportation context, hub is a place where transfers happen, right? Rather than people are connecting point to point or direct connections. So this hub operation can give you some economic efficiency, right? You can gain efficiencies in terms of cost as well as operations. You can increase efficiency by hub operations, right? But it is not the best always. Now, as I told you, low cost carriers operate point to point networks. They don't go through hubs because one drawback of hubs is hubs are congested most of the time because everybody concentrate activity at the hub. So the hubs are concentrated and it's expensive to operate at hubs because, let's say BIA during peak periods, their landing charges are high because that's a heavy demand period. So therefore, they are charging depending on the demand. Otherwise, everybody would want to come during the peak period. That's where the volumes are high. That's where the most passenger demand can be attracted to different airlines, right? So in most of the mega hubs, serving during the peak period is very expensive, right? So they price it in a way that they can manage their capacity, right? So therefore, hubs are expensive. These low-cost airlines operate at secondary airports, and they don't facilitate transfers, because this facilitating transfers is also an expensive business, right? So that is a service provided by the transport operator. So that's something, that's the characteristics of legacy carriers, right? Like Sri Lankan Airlines, Emirates, Singapore Airlines, and things like that. So it's very convenient from the passenger point of view, but at a higher cost. So the business model of low-cost carriers is they don't provide connections. So they provide point-to-point services. Their network is not kind of linked as at a hub. So they have point-to-point at a lower cost. So these point-to-point services are flexible, right? But can be certain times expensive. But hub operations can be little expensive, but can gain other efficiencies as well, because you operate it because your the benefits you gain are higher than the costs that are there, right? Yeah, so that's a brief discussion about hubs, but I really didn't specifically talk about hubs.
Who is
Did
the
I answer
feeder
your
for
question? Yeah.
Sri Lankan Airlines?
I beg your pardon?
Yeah, that Emirates, Sri Lankan Airline is a feeder for Emirates.
Okay, yeah, go ahead.
Yeah, then who is the feeder for Sri Lankan Airlines?
Okay, so this is how this operates. Now, it's Bandaranaike International Airport is a feeder airport for Emirates, not Sri Lankan Airlines, right? Sri Lankan Airlines operate Bandaranaike International Airport as their hub, right? So they bring in passengers from Dubai, they bring in passengers from India, they bring in passengers from Melbourne, and from various destinations in their network to Colombo. They concentrate everybody to Colombo, and they can provide connections at Colombo, because it is Colombo where their network points can be connected, right? So let's say one of their service points is Mumbai and another service point is Melbourne, Australia. So if Sri Lankan Airlines wants to connect a passenger from in Mumbai to Melbourne, they do it through Colombo. So it's Colombo is their hub, right? Colombo is their hub. So all the passengers who want to go to Melbourne from all their other destinations is concentrated to Colombo and put in one flight that is going from Colombo to Melbourne. So then you get higher load factors in every leg of your network. So that's one of the advantages of this hub operation. Otherwise, if you want to operate point to point, people who are going from Mumbai to Melbourne are very few, right? People who want to go from let's say Maldives to Mumbai, Dubai, Melbourne is very few. So it's very expensive or inefficient to operate a direct flight from between every OD pair, right? But if you concentrate everything to a hub and then through the hub you connect to the final destination, you can concentrate your demand to every flight leg or every leg of your hub. So you get higher load factors, you can get economies of scale. Now, the example I took for Emirates Airlines is when, so the what I wanted to make sure is that the difference between So at the same airport, BIA is a hub for Sri Lankan Airlines, and it's a feeder point for Emirates, because Emirates hub is Dubai. So they plan their schedule in a way that it is optimized connections at Dubai. So they bring in passengers from Colombo, they bring in passengers from all the other places to Dubai. And then they have large aircrafts like A380s connecting from Dubai to other major hubs in Europe and US. Is that clear?
Yes, sir. Thank you. My final question is, sir, that 3PL is a 3PL hub. We can consider 3PL as a hub.
Yes, we can do so. Like they are also basically doing something like this distribution center is doing, right? So they are getting supplies from multiple suppliers, and then they have their warehousing, and they do value addition, and then they sort them, consolidate them, and transport them to different customers, isn't it?
Yes, sir.
Right. So
Yeah, they are doing picking, packing, and transporting.
Yeah. So
Docking.
they docking. So they do some sort of consolidation at their distribution centers or warehouses. Right. Now if you want your goods to be transported directly from your supplier to your customer point, that will be very inefficient, isn't it? You don't have higher load factors in your vehicles. You have to use smaller vehicles. They are expensive in terms of cost per unit. What this 3PL service providers does is they concentrate all the activities through them. So they can then consolidate demand of multiple customers, and then they can achieve economies of scale. Is that all right? I mean, did I provide a sensible answer to you?
Yes. Yeah. Thank you, sir. Thank you very much.
So what about that Colombo port, that shipping, that port?
Yeah.
Is it a hub?
So we call it a transshipment hub, right? When the Colombo port. So Colombo port is we consider it as a major transshipment hub in our region, right? So Colombo port is served by large carriers, right? And it is strategically located along the east-west shipping lines where major carriers are going. And then we have other ports where these major shipping lines cannot reach, like this Indian ports and some ports in Pakistan and so on, right? So then a lot of transshipment happens between those ports and Colombo, right? So where these major lines are touching Colombo, and the cargo is transported between the major lines and the feeder ports at Colombo port. So therefore, we can call it as a hub.
Is it mean that that hub mean that like a central point, like?
Yes, correct. So it's a central point. It's where things are consolidated. One of the advantages, as I explained in the previous example, is that now if you try to connect point to point, now it is very expensive, and you don't have enough demand to connect individual points. So when you come to a hub, at a particular hub, demand from multiple locations are concentrated to a one destination. That's what we do at a hub, right? Now, even if you take a place like a bus terminal or a rail terminal, that's what happens, right? So everybody who wants to travel to Galle from different parts of Colombo come to Fort Railway Station, right? So otherwise, if you try to connect every individual towns with goal is very inefficient. You don't have enough demand, right? So you concentrate everybody to Fort railway station. Now you have a large demand of people going to Goa. So you put everybody in a big train and send them. So you can minimize the transportation cost. So that's what happens in a hub.
Okay, sir.
But the problem with hubs is you when you travel, when your transportation network have too many hubs, you have a lot of delays, and then you have a lot of risks of various disruptions at the hubs, right? Now, for example, now let's say a certain organization located in a landlocked country, right? Landlocked country, where your manufacturing goods have to go through several hubs to reach the final destination. So that involves a lot of handling costs. And also it involves a lot of delays, because as I told you, hubs are places where a lot of congestion. Like if you take Colombo port, it handles a lot of cargo volume. So there is congestion, right? So any containerized cargo does not get directly unloaded from one ship and loaded to another ship, right? May happen on some occasions, but most of the time what happens is cargo gets unloaded from a ship and held in a yard and then sorted, and then it's unloaded to another ship, right? So there is a delay and handling cost involved, and various disruptions are involved. So if you go through too many hubs, then one thing, you can't reach your market quickly, and you're subjected to a lot of disruptions happening in other countries, right? So that's why we market ourselves as a good location for foreign investment, as location for industries and manufacturing industries. We have a good port connecting, a good well-developed ports, and we are directly connecting markets from Colombo. So quickly we can reach other markets without a lot of handling and transshipments. So the main idea of a hub is you are concentrating activity.
Okay, sir. Thank you.
Anything else? Okay, so with that, I'll conclude my lecture. So thank you very much for being the audience or participating in this lecture, and I thank the Open University for having me as a resource person for this module. Okay, so if you have any questions, you can direct those through the module coordinator or the program coordinator to me. And so I'll conclude my lecture at this point. So thank you again, and have a pleasant evening.
Thank you, sir.
Thank you very much.
Thank you.
Thank you,
Thank you
sir.
very much, sir.